Clicks, hitting record. The essence, the defining equation for voltage, something that is always true for voltage, is it is the energy per charge. As an equation, volts equals energy. How is that spread out among the coulombs worth of time? I want you to think about that as you're doing this stuff. Voltage is energy density. Voltage is per capita income. Money. Energy is oomph per object. Energy is how thickly spread the butter is, not the total amount of butter, but how the bread is. Is the density of the ability to do stuff. How many joules per coulomb of electricity you got? Okay. This is always true. You can always talk about energy per amount of test charge. Voltage equals current times resistance. What many of you have done, I hope all of you have seen in lab, that is true for a particular thing called a resistor. Okay. Write that down, by the way. Definition of voltage is energy per charge, not IR. Definition of voltage is energy divided by charge carrying that energy, energy over charge. Definition of voltage is not V equals IR. Really, V equals IR is a statement about R, not about V. Again, was the hint I was giving out earlier, the hidden hint was what's F equals MA tell you? Is that the essence of A? You can solve A equals F over M, but is that what A means? How much force per kilogram? No. Acceleration's meaning is how does velocity change? Velocity over time. Change in velocity divided by change in time. That's the essence of A. It happens to be equal to net force divided by mass. That's secondary. Likewise, V equals energy, voltage is energy divided by charge is its core essence. V equals IR is a true statement, but it only applies sometimes, not universally. Okay, so as y'all saw in lab, I'm going to introduce you to Ohm's law, which also explains why pirates are all Buddhists. Did you know pirates are Buddhists? You can't have R without Ohm. Oh wait, I didn't tell you, the unit of R is Ohm. You saw that in lab. You should. Wait, I've got a couple people who aren't in that, right? Who aren't in Lab at West? Yeah, more than a couple, okay. By any chance, are you guys doing electricity in your downtown or Tempe labs? Not so much? Yeah. The order of labs is always different at different features. Okay, so here we go. Here we go. Let's focus on this. The idea behind V equals IR is how much. Think about this. Think about this. Here's a concept. Here's an analogy. You want to drink some soda, some milkshake, whatever, through a straw. You get more drink into your mouth, the harder you suck, yeah, right? Versus you get faster flow rate. The harder you suck, the more you get into your face hole. But the straw matters too. If you try to drink through a cocktail stirrer, that's hard, right? You would have to suck a lot to get the same amount of current, or equivalently, if you apply the same mouth suction, you're going to get very little I. If R is big, R is small, or V, it better be big too. What if you drank through a boba straw? If R is small, if the opposition to flow is small, any given amount of suckitude will give a big flow rate into your face, into your mouth. This is the essence of Ohm's law. It's how to drink a soda. The more pressure, electrical pressure, the more energy per charge you apply to a resistor, the more the flow rate happens. And you can have different flow rates depending on your resistor. Voltage is directly proportional to current in a resistor through the component called a resistor, and the constant of proportionality is the resistor's resistance measured in ohms, which I forgot to put on my slide again. The unit is the ohm. Now I should tell the pun about the pirates. Okay. I do want to make the point that Ohm's law is crappily named, not a law of physics. Laws are things that are always true. This is true for some things, but not all. Lots of things that are so-called non-ohmic. But in a resistor, a so-called ohmic device, like a wire or those packaged little carbon film things in the lab, this is a true statement. I guess it's called Ohm's law because Ohm's general tendency is too tedious to say. Now, this equation is important. We're going to focus on this for like 10 minutes here. But I want you to know that the idea, the meaning of him, the concept is like 10 times more powerful than the numbers. I will have you calculate with numbers. I will have you reason about the formula many times, well, twice in the homework, I think. If I recall correctly. But what I really want out of this is I want you to think about what it means, not just how to multiply and divide. Okay, write this down. You can calculate a resistor's resistance if you know its properties of the resistor. There is something called the resistivity of the material. This is the letter rho, Greek letter rho, slanty D. L is the length, how long the resistor is, and A is its cross section. If you look down the barrel of the resistor, don't worry, this isn't dangerous. Look down the barrel of the resistor. What's the cross section of that look like? Note, there are two words with similar sounds: resistance, resistivity. Different terms. What do you need to know to find out the resistivity? The only thing you need to know is what is the material made of. Iron has a resistivity. Steel has a different resistivity. Copper has a different resistivity. It does depend on temperature. We're not going to talk about that. So resistivity is something tabulated. You look it up in a book. If you know what your material is made of, know what kind of wire you've got, you know the resistivity. It doesn't change based on the size and shape of the wire. The size and shape of the wire does affect the resistance, however. The resistance of a given resistor, the resistance R, depends on not just what it is made of, but how big and long and fat it is. Do you see current in here? Do you see V in here? No. Muy importante. The essence, the central thing I want you to know about this equation is it tells you, most important thing, listen, write this down. The resistance of a resistor is not determined by voltage and current. It is determined by the properties of the resistor. It is determined by the properties of the resistor. Voltage and current don't set R. Voltage and current are set by R. R comes from the material and size and shape of the resistor. That's it. The resistance of a resistor tells you how much it opposes electricity. But the opposition to the electrical flow is not what makes a resistor have its resistance. Look, what's density? What is density? Luke, it is your density. No, not that. Luke is your destiny. What is density? Density is mass divided by volume, right? Does your mass control your density? No. You can calculate your density if you know your mass and your volume, but mass does not control density. What does control density? What you're made of. Your size, shape, and body fat percentage or whatever, BMI. So your density depends on your physical makeup, and that enforces a relationship between your volume and your mass. Your mass doesn't control your density. Okay. Likewise, resistance. What controls how easy the straw is to drink through? Is it your suckage? Is it what you do with your mouth to the straw? Does that control its size and shape? No. How easy a straw is to drink through, whether boba straw or garden hose or cocktail stirrer, what controls the property of, what controls the ease of drinking is the straw's properties. Calculate the straw's opposition to liquid with the straw's properties, then that controls the relationship between drinking rate and mouth suction. What's mouth suction in this analogy? Voltage. Voltage is the pressure. What's current in this analogy? How fast you swallow. The flow rate of liquid in your mouth hole. Okay. I've been talking too long. Here's a question. Come on. Oh, hey, it's not on. To answer this, please don't type out the words. Type out the letter or letters that you think apply. This is question, what are we on? B? B. Exercise B. Just tell me the letters that you think apply. What the what? What the sigma? This has died that fast. Hey, really sorry to distract. Does anyone have a decent USB-C charger they can borrow for the last period? Okay. I got a dainty little stupid power supply. Yeah. Yeah, this is a 20. This is like a 5. Okay, yeah, this will be better. Oh, poop. 4 is not long enough. Sorry. I mean, thank you, but anyone else have a big USB-C charger? I could either longer or just a bigger cube too. No, thank you. Yeah. Whoa, baby. Thank you. Okay. And now that my computer is not going to die in 5 seconds. Come on, please get there. Get in there. Good. Good boy. Now that my computer's not about to die, let's see what people's head. Hey, people are listening. Oh, that makes me happy. Correct answer, ABC. ABC. Again, especially if you got this wrong, write this down. The resistance of a specific resistor is controlled by the properties of the resistor, not the electricity. The analogy is how hard the straw is to drink through does not depend on what you do to the straw, depends on the size and shape of the straw.
Like, I'm just trying to understand better. So, like, let's say resistivity, you need the straw, like, for it. So, like, let's say a steel straw would be like less resistivity.
But the outside of the straw doesn't correspond to resistivity. To understand resistivity, we imagine that the straw is filled with foam. No, it's solid liquid wouldn't lock selectively. If you fill the inside of the straw with something porous, foam, Swiss cheese. Ew.
A sponge.
A sponge, yeah. The denser the spongy material, the bigger the resistivity.
Okay.
A normal straw without Swiss cheese inside, not Swiss. Yeah, Swiss. A normal straw without Swiss cheese inside would be a superconductor. Would have no opposition. So again, everyone got down the idea that the resistance depends on the resistor, not the electricity flowing through it. Great. Now we're going to spend some quality time with the mathematics of 7th grade. First, read carefully. Second, two wires, 1 and 2, A and B, whatever, you know what I mean, are made out of the same metal, but 2 is twice as long and twice the diameter of wire 1. Tell me the ratio, a ratio of the resistivities, rho. What are we on? C? This is exercise C. One minute. I want to see everyone take a stab at it. Take your best shot. You don't have to be perfect. Only I am perfect. Okay. All other things being equal, you could say goes up, goes down, or stays the same. Bigger, smaller, or equal. Take a stab at it. I want to see everyone answer at least that much. What do you think? Can you reason through? Come on, everyone at least put that much in. Take your guess. Okay, good. That's almost everyone. The correct answer is uno. It's the same metal. Resistivity is just tabulated if they're both made of iron, the same rho. They're both made of copper, it's the same rho. But there's an equation with rho in it. Who cares? Rho is just tabulated. If you know they're made of the same metal, doesn't matter what else there is. What other equations have rho in it? The same metal, the same value of rho. Correct answer for C is 1. May I see where you followed? Turn to your neighbor and discuss for 2 seconds. I want you to know what rho is. It sucks that they sound so similar. I'm sorry. Okay, ask me a question. Yeah. Which is denser? An iron ball that's this big or an iron ball that's this big? Right? Which is heavier, a pound of feathers or a pound of lead? Right? Look at the question carefully and think about what I'm talking about. Okay. Now, before I go on to the next thing, now it's math time for realties. I would like you to learn to reason or practice or revisit reasoning about a relationship between two numbers. Let us meditate upon the quadratic relationship. Y equals x squared. I'm going to ask you, if I do this to x, what happens to y? If I do that to x, what happens to y? In particular, I'm not going to tell you numbers. I'm going to tell you ratios. X doubles. By what factor does y change? Question D. X doubles. By what factor does y change? How does y change if I double x? X becomes twice as great. What happens to y? By what factor does y? Hey, time's up. If x becomes twice as great, what is a mathematical representation of twice as much x as was before? 2x, right? X final equals 2 times as much as the initial. Let's calculate y final and y initial and compare them. What happens when I plug 2x initial into the squared relationship? What happens when I say y final is x final squared? What's this evaluated to? If you said 2x squared, go to jail, go directly to jail, do not pass go, do not collect $200. If I square a product, both terms get the square. 4 x initial squared. Yeah. Let's compare y final to y initial. If I ask you the ratio, the factor by which y changes, y final, I'm asking y final divided by y initial. That's 4 x initial squared over y initial is the x initial squared. Pew, pew. If I double x, y quadruples, y becomes 4 times as great as it was. This is a very important thing we will see many times over. As a first example, although I want to go a little deeper, as a first example, write this down. If one thing is the square of the other, doubling the one thing quadruples the other. Again, I would like you to meditate upon this, my grasshoppers, to achieve physics enlightenment. If one thing is the square of another, doubling the one thing, square the quadruple of the other. People hate algebra. Many people hate algebra. Let's do something I call experimental arithmetic. Give me an x. Any number you want. 4, great. X is 4. What's y? If we double x, dot, 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 x becomes what? X final equals 8. What's y? 8 times 8 is What is the ratio of 64 to 16? Sixty-four is 4 times as great as 16. That's what I said before. All right, well, don't take my word for it. Maybe that's just because we picked x equals 4. Give me another x. How about 1? Oh, well, I should have let you guys do it. Let's start with x equals 1. What is y squared? Whoopsie. What is y? Oh, for dog's sake. Now what happens if I double x? What does x become? What happens if I, what is the new y? Y has become 4 times as great as it was. Okay, doubling is good. Doubling is great. I want you to be able to reason not just about doubling, but about any change. What if x triples? Make a prediction in question E. By what factor will y change if I triple x? Give me the number, the ratio of y final to y initial. You don't know y? Right there. Do you guys know the difference between x and y? X is someone you dated. Y is someone you really don't know how that came about. Wait, you speak German, right? Oh, gives away the pun. Nine. Hey, people get it right. Okay, the answer is a number, by the way. Let us experimental mathematics this. Give me a number, give me a number, give me a number. Anyone? 6, great. What's y? Last I checked, 36. What if we triple x? What is x now? 18. What's 18 squared? Yeah, good. What is the ratio of these two quantities? Anybody need a calculator? Go ahead. 324/36. I asked you to predict in E. If you're wrong, okay, whatever. What is the ratio? Yeah, 9. Yeah is the correct answer. Yeah, it is 9. Okay, so if I double x, y, no matter what x is, doubling x, y quadruples. If I triple x, y becomes 9 times as great. You think you see a pattern? What happens if x becomes 10 times what it was? Put this answer in F. By what factor will y change if I multiply x to be 10 times what it was? And you can use the methods that I've been showing you to reason about it. Correct answers. Oh, you make my cold dead heart beat again. Okay, time's up. Correct answer is multiplied by 100. Okay, what's the relationship? If I double, it goes up by a factor of 4. If I triple, it goes up by a factor of 9. So multiply by 10, the ratio is 100. What's happening to my multiplier? It's getting squared. Good. Now, hopefully I've prepped you better than the 3 o'clock class who 90% failed this question. Reason about this, dudes and dudettes and dude non-binary people.
Give this a shot in G. G for God if I know. God, I hope you do well. Please work together. Could be loud in here. I will remind you of the formula too. G, G. The density of the sponge. Friction coefficient. How much of an insulator something is on the insulator to conductor scale. It's not just that things are either insulators or conductors. There's a scale. How good, how bad resistivity is how bad that material is on average of conductor. The bigger the resistivity, the worse a conductor it is. Right, this. What's up on the board? And the exercise it is G. Put it in G. G is for Jesus. No, sorry, that does not. Yes, no, yes, no, yes, no. Okay. Okay, let's bring it together. What's happening to rho? Stays the same. So what happens to the fraction rho L over A? All of the things being equal, not changing rho does not change the fraction. Duh. What's happened to L? L doubles. What does it do to a fraction if you double the upstairs? What happens to A? No. Read the question. What do I do to the size, the fatness, the width of the wire? I double the diameter. Area and diameter are not the same. What, the same one? No. I'll be more lit next time. Much less skibbity, more lit. What's the relationship between area and diameter? What's the relationship between area and radius? Not 2 pi r. 2 pi r is circumference. Area is pi r squared. How's r related to d? Where is d? 2r. R is halfway across the circle. D is all the way across the circle. Dust off your geometry from middle school. If I double D, what happens to R? If I have a if I have a circle that is twice as big across, what does happen to R? Here, put this in question H. If I have a circle which is twice as big across, what has happened to its radius? Double the width of the wire, what's happened to R? And H. What happens to the radius when I double the width? I have drawn a pair of circles, by the way. This circle is about twice the diameter of this. What does happen to the radius of these circles? I will remind you all that you must try these. If you are not answering any of these, I will assume you are asleep and you will not get participation points. You must attempt, make a guess, talk to your neighbors and give something. Okay, 90% of you have correctly got that if you have twice as wide a wire, its radius is also twice as great. If D equals 2R, doubling D doubles R. What does doubling R do to A? What do we just say about this kind of mathematical relationship? Form the ratio of when R is twice as great as it was. What do I get? I've got a quadratic relationship. R is squared, so the doubling squared as well. Double squared is 4 times as great. No, you don't like that? Okay. Circles are hard. Nobody understands circles. Talk about a square. Squares are easy. What happens if I double the side length of a square? Area of a square is just its side length squared, right? For a square, A equals S squared. What happens if I've got twice as much S? Hey, nice. No, anyway. Here's got a thing. How much larger is the area? 4 times as great. What happens if I add 3 times the side length? How many squares would it take to tile this bathroom floor? 3 squared is 9. If I've got a quadratic relationship, whatever multiplier you have gets squared in the final ratio. Turn to your neighbor and express this thought to each other, please. Muy importante. I will ask this on the final, guaranteed at least 3 or 4 times in different forms. This process of reasoning about how does this change that, ratio problems, given here's some physical formula. How does this affect that? That structure will be for current questions. I want the skills to be solid. Hey, ask me a question. We're not done yet. Ask me a question. Where are you struggling? What's weird? True. True. And what happens if radius doubles? True. And so what happens to A? Pi squared is A. Yeah. No, you just said pi squared quadruple. Yeah, A quadruple. That's all. You got it. Good. Now, final question. We've got 3 factors. Rho stays the same. L doubles, A quadruples. How? Let's do this Google form. Question I. If I do, this is G is I again. I want you to take a second stab at this. By what factor does R change if I do this? I have given you guys a process to reason about rho, L, and A. How does the problem statement affect rho, L, and A? Now I want you to give me a final answer again. So many correct answers. Oh, I'm happy. You guys are better than the 3 o'clock. Doing better and better people in this. What happens to R if I keep row the same, double L and quadruple A? By what factor does R change?
Big O. It's too many R's.
R.
Radius.
This stays the same. This doubles. This becomes 4 times what it was. How does the fraction? That's the fraction.
Oh.
More bigger numbers.
Plug them in. Plug them in. What do you get? 30 seconds. If you're still not getting this, if you're still not taking up the sick beat that I'm laying down, we will revisit this approximately 17 times in the semester. Not know it's sort of kind of will feel like that anyway. I also said, again, basically, 4 questions on the final. Basically, you cannot get an A on the final. You will lose a letter grade if you do not eventually pick this skill up. Yes, I'm serious about you learning this. I really believe that this is important, very foundationally important. You got more than one chance. Correct answer is a half, by the way, for this. We will revisit this. You must eventually learn. I will get you there. Yeah, please, question me. The whole fraction. R. R equals rho L over A. This needs to say this doubles this quarter. Fraction. Let's see what I Rho stays the same. L becomes twice, A becomes 4 times. Rho L over A halves. Good, good, good. Then you're going to do well in the final. At least that section. Give me another question. He's asking questions. I love that. Give me more. Ask me why. Yeah, David. Will a wire always be a circle? Absolutely not, but most often, and I will usually assume. I've got some square wire in my lab. Not my lab, in the lab I use. But we will usually talk about circular wire. Other questions? Move on. Okay. We have discussed this in lab, but not everyone's in lab. So let's talk about a couple of things. Also, I told you the answers to these already. Give it a shot in J, and then I'll give you a hint. Tell you the answer. Reason about the formula you got. Come on, talk to each other. It should be louder in here. I is current. Originally, the name for current was intensity.
Okay.
I replace a boba straw with cocktail straw. What happens to my? Sorry. Hint. So I replace a boba straw with cocktail straw. What has happened? What happens when I try to drink? Okay, second hint, I've got an equation for B equals IR, voltage across a resistor, through that resistor times the resistance of that resistor. What happens if I change I must change the resistor, by the way. Remember, changing voltage and changing current doesn't change the resistor. If you want to change the resistor, you gotta put the resistor in place, or I guess make it longer, thinner, in the material magically. That's what changes. I replace the resistor with something of a higher resistance. Does V change or does I? I'm connected to a battery. What have you learned about batteries? It's a crime, first off. Not that kind of battery. Maybe this battery makes you think of that kind of battery. Okay, so if I've got a 9-volt battery and I attach a stronger light to it, what's its voltage? 9-volt battery. What if I take the lamp off the 9-volt? What's its voltage? It's a 9-volt battery. Battery voltage is a property of the battery. Batteries will supply more or less current, but their V is held the same. The battery supplies the same voltage to the resistor. What can we conclude? If V is equal and R goes up, what happens to I? Show me with your hands. I hear like 5 people. Show with the hands. Does it go up? Does it go down? Does it stay the same? Does it down? If V stays the same, no, show me loud. Show me, or not loud. Out, big. Show me with your hands. Yeah, you guys got it. It goes down. V stays the same, and I decrease one thing in a product. I must increase one thing in the product. Must decrease the other. Good. Follow up. K. Correct. Love it when the first thing I see is the right answer. One minute. So many correct answers. Which I hope there should be, as I did just tell you the answer to this question. Stays the same. What did we just say about a 9-volt battery? What's its voltage? Yeah, it is 9. Right? That's what it means to be a 9-volt battery. It always tries to maintain a steady 9 volts across its terminals. So V equals IR, I up R. What does change? What did we just discover changes? Current. I. Good. Okay, this I want you to derive. I will give you a big fat hint, 2 big fat hints. What's power? The ability to crush your enemies. No, not that kind of power. Power equals, yeah, what's a watt? Watt's a watt. Joules are energy. Seconds, last time I checked, was time. You must now tell me, question L, the equation which links these 3. I'm not going to tell you, you tell me. Look at these defining equations, energy per time charge per time and energy per charge. How could these possibly equationally be related? An equation relating these. Dun, 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 correct. Dun, 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 correct. Not V equals IR. I want P related to I and V. I don't want R in this equation. I'm asking the relation between P, I, and V. Look at the meaning of P, I, and V and tell me how they must be related. Salesman. Here's an analogy. Charge is the person. No, one charge is one person. Energy is how much money they're going to pay to get in past enter my event. Time is time. What's power then? Energy per time is dollars per second. How fast you're earning money for whatever, for your capitalist overlords. What's I? What's current? What does it feel like? What's it taste like? What is the analogy for charge per time? It's how many people per second are entering your building. What's energy divided by charge? Tell you. How much money each person has to pay. Voltage is the density of money, sort of. Current is the rate at which they're flowing. What do I have to do if I know how many people per second are passing and how many dollars per person? How could I relate these to dollars per second? I multiply. Well, I adopt, but one can multiply. Power equals current times voltage, that's all there is to it. Look, if I multiply charge per time by energy per charge, charge dies, and I'm left with energy divided by time. Him. All there is to it. Hey, what if I give you a problem? I will give you a problem on homework that asks you to find the energy deposited in a resistor or whatever. How could you find energy given stuff? What could I do with these terms to get energy out if I tell you electricity terms? If I want energy and I tell you about current and voltage and stuff, what would you need to know? Power is given by now if I know the electricity terms, I know current and voltage. If I know power is current and voltage, how do I get energy out? Multiply by time. Exactly. Power times time is energy. Rearrange the binding equation. Yeah. What happens if I give you resistance and current? How could you find power given resistance and current? If you know PIV, if you know VER, and I just tell you, if I just tell you current And resistance, how could you find P? Well, I know PIV. How could I get V? Shove it. Take this equation, shove it in. Power is also equal to current times voltage, which goes by the fancy pants name of current. That was a test in. Okay. Current squared times voltage. P equals I squared R. Sure. Don't memorize that as a separate equation. You got I, you got R. Of course you could find V and then pivot up. You can pivot to the correct answer. What if I tell you V and R? How could you find PIV? Power. I would find I first. I is V over R. Take this and shove it into the equation. I get P equals V over R times V. How can I simplify V over R times V? V squared divided by R. Three equivalent ways of writing the same thing. Sometimes one will be useful, sometimes the other will be useful. You can always use the definitions of power in terms of current voltage. Definition of Ohm's law. Different definitions. You can always use the equations PIV and inverter to solve for any variable you want. Or for any. Give me a question. But anything we've covered. No, wait. First, turn to your neighbor. Look over the notes for today. It has been a minute, right? We have done a fair bit of dabbing on physics. So take a look over your notes for today. Revisit them, review them, and I want some questions about where you are most confused. But what happens if D&D doubles? All right, cowboys, cowgirls, and all other states of cow persons, as well as actual cows. No way, you're all people. Never mind. I think. Plot twist. Anyway. Give me a question. I demand questions. I'm a question vampire. Where are you struggling? What's weird, man? Yeah.
Explain slide 9.
Yes. Slide 9. Yeah, I can explain slide 9. Okay, the conceptual idea behind this is a battery will do whatever it needs to do to keep its V the same. So if V don't change, the voltage the battery supplies to the resistor, the voltage, the pressure, the suck factor on straw doesn't change. What happens to I when I change R? If R goes up, I'm multiplying by a bigger number. When I get the same result, I has to go down. If I multiply a big number by a bigger number, I'll get a bigger number. I have to multiply a bigger number by a smaller number if I want to do these. current doesn't change in some circumstances if I keep if I have a series circuit, one after another, the current is the same one and the other, this is a different situation. It is not true that current is always the same. That's it, yeah.
Is the only reason why, because I thought you weren't supposed to change, numbers on the same side of the equation, like they don't affect each other.
Well, fine, I can solve for a variable. If I want to know about current, solve for current. There. Now, I and R are on different sides of the equation. How does increasing the downstairs affect? If I divide by a bigger number, what happens to I? Upstairs stays the same because battery. Downstairs increases, what happens to I? Oh, you divide by a bigger number, you get smaller fraction. Yeah. Voltage. If I have a battery, if I don't change the battery, the voltage it applies is the same. To a external circuit.
No. So this, as you did last, like, don't draw anything, the voltage will stay the same.
So the voltage across the battery will stay the same. Please note, you got a series circuit. It's not true that the voltage everywhere is the same. The voltage across the battery is not affected by the resistor's resistances. What did change in the lab was as you change the which resistors are attached, current changes. That said, the batteries in the lab are getting old and lots of students are using them. So there's also a complicating factor called internal resistance. Don't go there. Not yet. One more question, yeah. I give you my professorial dispensation to rearrange any formula you want. Yeah. Solve for what you want to reason about, what you want to know about, and then manipulate variables. Sure. Totally legal. Unless you make a mistake in the algebraic rearrangement, then you're screwed. Okay, whose device did I borrow again? That was David, yeah. Thank you. Again.